So I was on my right here, and I was already on my output. So, all right. Looks like everybody's back here. So now let's go back to the last area where I discussed. So the standard error of the estimate is 3.78, but I'd like to emphasize this is the model summary. So this model utilizes the parameter that the mean score of the NCE is 30. If you repeat the same experiment, or if you repeat the same study and your mean is no longer 30.27, your standard error of the estimate will no longer be 3.78. So this standard error of the estimate is very dependent to the mean score of the NCE, because the mean score is the parameter that is being used by the model of the regression model for this particular sample. Remember that that regression and maximum likelihood estimation is looking at the best fit of the data. It's looking at the realistic dynamic relationship of the variables in a given population. So that's how we interpret standard error of the estimate. Here's the ANOVA, which is an important part of our regression output on SPSS. It uses the F statistics, and the F statistic value is 4.404. And for those of you who have statistic books, you will always look at the end part of the book. It always gives you the normal distribution for the Z-score, and on a t-test, what are the t statistics at the different significant value, and then this is an F statistics. ANOVA uses F statistics, and for this it gives you the output that the F statistics for this particular data set is 4.404, and it's 0.039. And that's exactly the same as we get from simple correlation. That was the look at here. Right here, and the first thing that we did was the simple correlations, 0.039. That is exactly the same as our ANOVA value that we get in our regression, 0.039. That's the statistical significance, or our p-value for this particular data set. So now this is the most important part, coefficient. So this is what regression is all about. This is the most important. So if I have a paper, and if I'm going to publish my result, I'm not going to tell the reader about the model summary, the standard error of the estimate. I'm not going to tell them that the ANOVA is the same statistical significance as 0.039 that I got as in my simple correlations, because that's not what regression is all about. What regression is all about are coefficients. So let's really understand this part of the SPSS output is the coefficient. So right here in our model, the constant is 1. And what did I say about constant on maximum likelihood estimation? That the constant is the intercept, okay? So it's very weird why SPSS called it constant, but this is the intercept. So what is the standardized coefficient? What is the beta coefficient? There you will see again, it's 0.221. And where do we get that 0.221? Right here. That was our R value. 0.221 is what we get. So that comes back here in the coefficient is 0.221. And the t-statistics is 2.009. And our significance is 0.039. So this is the proof of the concept that ANOVA, simple correlations, and simple linear regressions can give you the same result. Any question at this point? Am I able to demonstrate that they're all 0.039? We got the same thing, same results. But the biggest question then is, what does regression add? What does it add that we didn't get from our... So when we do correlation, we were able to look at the association, the strength of the association. It's 0.221. The simple correlation will tell you it's a weak correlation. Yes, there is association that the higher the IQ, the higher is the NCEE score. But that correlation is very weak. It's only 0.221, which in correlations, the higher the R, the higher is the correlation. So if we would have a 0.89, if we would have a 0.9, that's a very high correlation. That's a very strong association. And that has more predictive power because that's higher. But for us, we only get 0.221 in our simple correlations. And what does this regression coefficient tell us? Well, because it uses a coefficient, we can look at the unstandardized coefficient. What it tells you here is that the constant is the unstandardized beta coefficient is 14. What it tells you is that if your IQ is 0, your NCEE score will be 14. That's what it means, okay? Because it is in regression modeling, your independent variable is the predictive variable. So if I go back here, in regression modeling, the intercept, which is labeled as the constant, is the expected mean value of the dependent variable, which is NCEE, when the independent variable is 0. So what this means then is that if my independent variable, if my IQ is 0, I could expect, that's the predictive power of the independent variable, I will get an NCEE score of 14. And the NCEE score, the mean value that we got was 30.27. So it tells you that if your IQ is 0, you're only going to get 14 of the